Question 1. Process analysis reveals that a new cloud-based customer relationship management (CRM) application is being integrated into the enterprise network. This application will handle sensitive customer data, including personal identifiable information (PI) and financial details. The IT department is tasked with designing the network security posture for this integration. Which of the following approaches best aligns with a robust and compliant enterprise network design strategy for this scenario? Option A. Conduct a thorough risk assessment to identify critical assets, potential threats, vulnerabilities, and the likelihood and impact of security incidents related to the CRM application and its integration points. Based on this assessment, implement targeted security controls and policies. Option B. Rely entirely on the security measures provided by the cloud CRM vendor, assuming their infrastructure is inherently secure and sufficient for all organizational needs. Option C. Prioritize the selection of the least expensive security solutions available to protect the CRM application, focusing on immediate cost savings. Option D. Implement a broad, restrictive firewall policy across the entire network to block all non-essential traffic, assuming this will inherently protect the new CRM application. The correct answer is A. Conduct a thorough risk assessment to identify critical assets, potential threats, vulnerabilities, and the likelihood and impact of security incidents related to the CRM application and its integration points. Based on this assessment, implement targeted security controls and policies. Explanation. Scenario analysis. The scenario presents a common challenge in enterprise network design, balancing the need for robust security with the operational requirements of a business. The introduction of a new cloud-based application introduces potential vulnerabilities that must be identified and mitigated without unduly hindering user productivity or incurring excessive costs. The challenge lies in accurately assessing the risk landscape, which involves understanding the application's data sensitivity, its integration points with existing infrastructure, and the potential impact of various threat vectors. This requires a systematic approach to risk assessment that considers both technical and business implications. Correct approach analysis. The correct approach involves a comprehensive risk assessment that prioritizes threats based on their likelihood and potential impact. This aligns with best practices in cybersecurity and network design, emphasizing a proactive rather than reactive stance. By identifying critical assets, e.g., sensitive customer data, analyzing potential threats, e.g., unauthorized access, data breaches, and evaluating existing controls, a clear picture of the risk posture emerges. This allows for the selection of appropriate mitigation strategies, such as implementing strong authentication, encryption, and network segmentation, which are cost-effective and proportionate to the identified risks. This methodical process ensures that security investments are targeted and effective, adhering to the principle of least privilege and defense in depth, which are foundational to secure network architecture, as outlined in industry standards and Cisco's own security design principles. Incorrect approaches analysis. Implementing a broad, blanket security policy without a specific risk assessment is an inefficient and potentially detrimental approach. It can lead to over-provisioning of security measures, impacting performance and user experience unnecessarily, or under-provisioning in critical areas if the assessment is flawed. This lack of targeted mitigation fails to address the unique risks posed by the new application and its integration, potentially leaving the organization exposed. Furthermore, it deviates from the principle of risk-based security, which is a cornerstone of effective cybersecurity programs. Focusing solely on the cost of security solutions without considering their effectiveness in mitigating identified risks is also a flawed strategy. While budget is a constraint, prioritizing the cheapest option over a more effective, albeit potentially more expensive, solution can lead to significant financial and reputational damage if a breach occurs. This approach neglects the potential business impact of security failures, which can far outweigh the initial cost savings. It also fails to meet the ethical obligation to protect organizational assets and customer data. Ignoring potential threats and assuming the cloud provider's security is sufficient is a dangerous oversight. While cloud providers offer robust security, the shared responsibility model means that the organization is still accountable for securing its data and applications within the cloud environment. A lack of proactive threat identification and mitigation leaves the organization vulnerable to threats that the cloud provider may not be responsible for addressing, such as misconfigurations or application-level vulnerabilities. This abdication of responsibility is a significant ethical and professional failure. Professional reasoning. Professionals should adopt a structured risk assessment methodology. This involves 1. Asset identification. Clearly define what needs to be protected. 2. Threat identification. Brainstorm potential threats to those assets. 3. Vulnerability assessment. Identify weaknesses that threats could exploit. 4. Risk analysis. Determine the likelihood and impact of identified risks. 5. Risk evaluation. Prioritize risks based on their severity. 6. Risk treatment. Select and implement appropriate mitigation strategies, e.g., avoidance, mitigation, transfer, acceptance. 7. Monitoring and review. Continuously assess the effectiveness of controls and update the risk assessment as needed. This systematic approach ensures that security measures are aligned with business objectives and effectively manage the organization's risk exposure. Question 2. Analysis of a proposed enterprise network design for a multinational corporation reveals a focus on high throughput and low latency for critical business applications. However, the design team has not explicitly documented how this design will meet the data privacy and protection requirements mandated by the General Data Protection Regulation, GDPR, for customer data processed within the network. Which of the following approaches best addresses this oversight from a regulatory compliance and professional responsibility perspective? Option A. Conduct a comprehensive risk assessment that specifically identifies GDPR-related data privacy requirements and integrates them into the network design, including measures for data encryption, access control, and data minimization. Option B. Rely on the legal department to provide a definitive list of all GDPR requirements that the network must adhere to, without direct involvement from the network design team in interpreting or implementing these requirements. Option C. Prioritize the technical performance objectives of the network design and address any potential GDPR compliance issues in a subsequent operational phase after the network is deployed. Option D. Assume that existing general security protocols implemented across the organization are sufficient to meet GDPR requirements, as they are designed to protect sensitive information. The correct answer is A. Conduct a comprehensive risk assessment that specifically identifies GDPR-related data privacy requirements and integrates them into the network design, including measures for data encryption, access control, and data minimization. Explanation. This scenario presents a professional challenge because the network design team is tasked with implementing a new enterprise network that must not only meet performance and scalability requirements, but also adhere to stringent data privacy regulations. The challenge lies in balancing the technical design choices with the legal and ethical obligations to protect sensitive customer data. A failure to adequately consider these regulations during the design phase can lead to significant legal penalties, reputational damage, and a loss of customer trust. The correct approach involves a proactive and integrated risk assessment that considers regulatory compliance from the outset. This means identifying all applicable data privacy laws and guidelines relevant to the enterprise's operations and customer base, and then mapping these requirements to specific design decisions. For example, if the enterprise handles personally identifiable information, PI, subject to regulations like GDPR, assuming a relevant jurisdiction for the exam context, the design must incorporate measures for data encryption, access control, and data minimization. This approach represents best professional practice because it embeds compliance into the core of the network architecture, rather than treating it as an afterthought. It demonstrates due diligence and a commitment to ethical data handling, which is increasingly mandated by regulatory bodies and expected by the public. An incorrect approach would be to prioritize only technical performance metrics, without a thorough understanding of the regulatory landscape. For instance, selecting a network architecture that facilitates rapid data transfer but lacks robust encryption or access controls for sensitive data would be a regulatory failure. This could lead to unauthorized access or data breaches, violating data privacy laws and resulting in fines and legal action. Another incorrect approach would be to assume that standard security measures are sufficient without specific validation against the applicable regulatory framework. This oversight could result in non-compliance with specific mandates regarding data retention, consent management, or breach notification, all of which carry significant ethical and legal ramifications. Professionals must understand that regulatory compliance is not a generic security concern, but a specific set of legal obligations that require explicit consideration and implementation within the network design. The professional decision-making process for similar situations should involve a multidisciplinary approach. Network designers must collaborate with legal counsel, compliance officers, and security experts to gain a comprehensive understanding of all relevant regulatory requirements. A structured risk assessment methodology should be employed, which includes identifying potential threats and vulnerabilities, assessing their impact in the context of regulatory noncompliance, and developing mitigation strategies that are both technically feasible and legally sound. Continuous monitoring and periodic reassessment of the design against evolving regulations are also crucial components of responsible network design. Question 3. The monitoring system demonstrates a consistent pattern of elevated latency and intermittent packet loss affecting user access to core business applications. Which of the following risk assessment approaches is most appropriate for diagnosing and resolving this issue in an enterprise network environment? Option A. Focus solely on increasing bandwidth across all network segments to alleviate potential congestion. Option B. Conduct a comprehensive root cause analysis by correlating performance metrics with recent configuration changes, traffic flow data, and device health logs to identify the most probable contributing factors. Option C. Immediately initiate a network-wide configuration rollback to the last known stable state, assuming a recent change is the cause. Option D. Attribute the performance degradation to external internet service provider issues and await their resolution without further internal investigation. The correct answer is B. Conduct a comprehensive root cause analysis by correlating performance metrics with recent configuration changes, traffic flow data, and device health logs to identify the most probable contributing factors. Explanation. The monitoring system demonstrates a significant increase in network latency and packet loss across critical enterprise services. This scenario is professionally challenging because it directly impacts business operations, potentially leading to financial losses, reputational damage, and user dissatisfaction. The network designer must quickly and accurately assess the root cause of these issues to implement effective remediation strategies while adhering to established design principles and operational best practices. The challenge lies in distinguishing between transient anomalies and systemic design flaws that require architectural changes. The correct approach involves a systematic risk assessment focused on identifying the most probable causes of the observed performance degradation. This includes analyzing traffic patterns, device health, configuration changes, and potential external factors. By prioritizing investigation based on the likelihood and impact of potential causes, the designer can efficiently allocate resources and minimize downtime. This aligns with best professional practice by ensuring a data-driven, methodical approach to problem solving, which is implicitly supported by industry standards for network reliability and resilience. While specific regulations for network design are not explicitly mandated in the ENSLD exam context, the principles of due diligence, risk mitigation, and operational integrity are paramount. An incorrect approach would be to immediately implement drastic, unverified changes without a thorough understanding of the underlying problem. For instance, randomly reconfiguring network devices or increasing bandwidth without identifying the bottleneck is a failure of due diligence. This could introduce new, unforeseen issues, exacerbate existing ones, or be a costly and ineffective solution. Ethically, this approach demonstrates a lack of professional responsibility to thoroughly investigate and understand the impact of proposed solutions. Another incorrect approach is to dismiss the issue as a temporary anomaly without sufficient evidence, which could lead to a recurrence of the problem and significant business disruption, failing to uphold the professional obligation to ensure network stability and performance. Professionals should employ a structured decision-making process that begins with clearly defining the problem and its impact. This is followed by hypothesis generation, data collection and analysis, and the evaluation of potential solutions based on their effectiveness, feasibility, and risk. The process should involve collaboration with relevant teams and stakeholders, and any implemented changes should be carefully documented and monitored. This iterative approach ensures that solutions are targeted, effective, and contribute to the overall resilience and performance of the enterprise network. Question 4. System analysis indicates that a US-based investment bank requires a network design that guarantees the lowest possible latency for its high-frequency trading (HFT) platform and ensures the integrity of its regulatory reporting data, all while operating under the stringent oversight of the Securities and Exchange Commission (SEC) and the Financial Industry Regulatory Authority (FINRA). Which of the following CoS design approaches best aligns with these critical business and regulatory imperatives? Option A. Deploy a best-effort CoS model across the entire network, assuming that increased bandwidth will naturally mitigate any latency issues for all traffic types. Option B. Implement a hierarchical CoS model that classifies and prioritizes HFT traffic using strict priority queuing and ensures regulatory reporting data is marked with a high DSCP value for weighted fair queuing, while applying policing to non-essential traffic. Option C. Prioritize general employee internet browsing and video conferencing traffic using strict priority queuing, with HFT and regulatory reporting data receiving only standard queuing. Option D. Focus on aggregating bandwidth across all network links without implementing any specific traffic classification or prioritization mechanisms. The correct answer is B. Implement a hierarchical CoS model that classifies and prioritizes HFT traffic using strict priority queuing and ensures regulatory reporting data is marked with a high DSCP value for weighted fair queuing, while applying policing to non-essential traffic. Explanation. Scenario analysis. Designing a robust and secure enterprise network requires a deep understanding of various design principles, including quality of service, CoS. In a scenario where a financial services firm, operating under strict U.S. regulatory frameworks like those overseen by the SEC and FINRA, needs to prioritize critical trading data over less time-sensitive traffic, the challenge lies in implementing a CoS strategy that not only meets performance demands, but also adheres to compliance requirements. The firm must ensure that its network infrastructure can guarantee the timely delivery of financial transactions, audits, and regulatory reporting, while also managing bandwidth effectively for other applications. Failure to do so could result in financial losses, regulatory penalties, and reputational damage. The professional challenge is to balance technical efficacy with regulatory mandates, ensuring that the design choices are both technically sound and legally defensible. Correct approach analysis. The correct approach involves a hierarchical CoS model that prioritizes critical traffic at multiple points within the network, from the edge to the core. This typically includes mechanisms like classification and marking of traffic, e.g., using differentiated services code point DSCP values, queuing strategies, e.g., strict priority queuing for trading data, weighted fair queuing for other traffic, and policing/shaping to manage bandwidth. For a U.S. financial services firm, this aligns with regulatory expectations for operational resilience and data integrity. For instance, SEC Rule 17 A4 mandates specific data retention and retrieval capabilities, which are indirectly supported by a reliable network. FINRA regulations emphasize the need for firms to have robust systems to prevent fraud and manipulation, which includes ensuring the integrity and timely processing of trades. A well-designed CoS strategy directly contributes to this by ensuring that critical financial data is not delayed or dropped, thereby maintaining compliance with the spirit and letter of these regulations. This approach demonstrates a proactive understanding of business needs and regulatory obligations, ensuring that the network design supports both operational efficiency and compliance. Incorrect approaches analysis. Implementing a best-effort CoS model, where all traffic is treated equally, is professionally unacceptable for a financial services firm. This approach fails to acknowledge the critical nature of financial transactions and regulatory reporting. Ethically and regulatorily, it creates a significant risk of data loss or delay, which could lead to non-compliance with SEC and FINRA rules regarding timely transaction processing and data integrity. Such a failure could be interpreted as negligence in maintaining adequate systems and controls. Adopting a CoS strategy that prioritizes non-critical applications, such as employee entertainment or general web browsing, over financial data is also a severe professional and regulatory failure. This directly contradicts the business's core function and regulatory obligations. It demonstrates a lack of understanding of business priorities and a disregard for compliance requirements, potentially leading to significant financial and legal repercussions. Focusing solely on bandwidth aggregation without implementing granular traffic prioritization mechanisms is another incorrect approach. While increasing bandwidth can alleviate congestion, it does not guarantee that critical traffic will receive preferential treatment during periods of high demand. This can still lead to delays and packet loss for essential financial data, violating the implicit and explicit requirements for reliable financial systems under U.S. regulations. Professional reasoning. Professionals designing enterprise networks for regulated industries must adopt a risk-based approach. This involves identifying critical business functions and the network requirements to support them, then mapping these requirements against relevant regulatory frameworks. The decision-making process should prioritize solutions that demonstrably enhance reliability, security, and performance for critical operations. When evaluating CO-S strategies, professionals should ask: 1. Does this strategy ensure the timely and reliable delivery of critical business data as mandated by regulations? 2. Does it provide mechanisms for granular control and prioritization of traffic based on business criticality? 3. Are the chosen CO-S mechanisms auditable and verifiable to demonstrate compliance? 4. Does the design account for potential network congestion and ensure that critical traffic is protected? By systematically answering these questions, professionals can ensure that their network designs are not only technically sound, but also compliant and ethically responsible. Question 5. Research into best practices for securing a Cisco enterprise network reveals a need to protect sensitive financial data. The design must prevent unauthorized access to financial servers and mitigate the risk of internal threats. Which of the following design approaches best addresses these requirements while maintaining operational efficiency? Option A. Deploy a single, high-performance firewall at the network perimeter with a default deny policy for all inbound and outbound traffic, allowing only explicitly permitted connections to the financial servers. Option B. Implement a comprehensive security strategy that includes network segmentation to isolate financial servers, granular access control lists, ACL, to enforce the principle of least privilege for users and applications accessing these servers, and an intrusion prevention system, IPS, to monitor for and block malicious traffic patterns. Option C. Configure extremely restrictive ACLs on all network devices, blocking all traffic by default, and requiring manual approval for every single connection attempt to any server, including financial servers. Option D. Focus solely on encrypting all data in transit to and from the financial servers, assuming that strong encryption will inherently prevent unauthorized access and internal threats. The correct answer is B. Implement a comprehensive security strategy that includes network segmentation to isolate financial servers, granular access control lists, ACL, to enforce the principle of least privilege for users and applications accessing these servers, and an intrusion prevention system, IPS, to monitor for and block malicious traffic patterns. Explanation. This scenario presents a common challenge in enterprise network design, balancing the need for robust security with the operational requirements of a dynamic business environment. The professional challenge lies in interpreting and applying security best practices within the constraints of a real-world deployment, where immediate business needs can sometimes conflict with long-term security posture. Careful judgment is required to ensure that security measures are effective without unduly hindering legitimate business operations or introducing unnecessary complexity. The correct approach represents best professional practice because it prioritizes a layered security strategy that is both comprehensive and adaptable. By implementing a combination of network segmentation, access control lists, ACL, and intrusion prevention systems, IPS, the design addresses multiple attack vectors. Network segmentation limits the blast radius of a potential breach. ACLs enforce the principle of least privilege, and IPS actively detects and mitigates threats. This multifaceted approach aligns with industry-standard security frameworks and Cisco's own design principles for enterprise networks, emphasizing defense in depth. It also allows for granular control and monitoring, which are crucial for maintaining compliance and responding to security incidents effectively. An incorrect approach that focuses solely on implementing a single security control, such as only deploying a firewall without considering internal segmentation or access controls, is professionally unacceptable. This failure stems from an incomplete understanding of modern threat landscapes, which often involve lateral movement within a network. Relying on a single point of defense creates a critical vulnerability if that control is bypassed or compromised. Ethically, this demonstrates a lack of due diligence in protecting organizational assets and data. Another incorrect approach that involves deploying overly restrictive ACLs that block legitimate business traffic is also professionally unacceptable. Security is paramount. Network design must also support business operations. Overly restrictive policies can lead to significant operational disruptions, impacting productivity and revenue. This approach fails to strike a balance and can be seen as a failure to adequately understand the business context, leading to a technically secure but practically unworkable network. This can also lead to frustration and workarounds that bypass security controls, ultimately weakening the overall security posture. A third incorrect approach that neglects to implement any form of intrusion detection or prevention is professionally unacceptable. This oversight leaves the network vulnerable to known and emerging threats that may circumvent perimeter defenses. It represents a failure to proactively monitor for and respond to malicious activity within the network, which is a fundamental aspect of modern network security. Ethically, this demonstrates a disregard for the potential harm that can be caused by security breaches, including data loss, financial damage, and reputational harm. The professional reasoning process for similar situations should involve a thorough risk assessment, understanding of business requirements, and adherence to established security frameworks. Designers must engage with stakeholders to understand critical business functions and data flows. They should then apply a defense-in-depth strategy, selecting and configuring security controls that are appropriate for the identified risks and operational needs. Continuous monitoring, regular review of security policies, and a commitment to staying abreast of evolving threats are also essential components of professional network design. Question 6. Strategic planning requires a comprehensive evaluation of security best practices when designing a new enterprise network. Given the increasing sophistication of cyber threats and the need to protect sensitive corporate data, which of the following design approaches best balances immediate operational needs with long-term security posture and regulatory compliance? Option A. Focus exclusively on strengthening perimeter security defenses, assuming that internal network security can be addressed as a secondary concern once external threats are neutralized. Option B. Prioritize the implementation of foundational security controls such as network segmentation and robust access control policies, followed by a phased integration of advanced security measures based on evolving threat intelligence and business risk assessments. Option C. Deploy a single, comprehensive security solution that aims to cover all potential threats across the entire network infrastructure without specific regard for internal network segmentation. Option D. Defer the implementation of advanced security architectures, such as zero-trust principles, until they become industry standard and widely adopted, opting for a more conservative, reactive security stance. The correct answer is B. Prioritize the implementation of foundational security controls such as network segmentation and robust access control policies, followed by a phased integration of advanced security measures based on evolving threat intelligence and business risk assessments. Explanation. Scenario analysis. Designing a robust and compliant enterprise network requires a deep understanding of the Cisco Enterprise Network's architecture principle, particularly in the context of security and scalability. The challenge lies in balancing immediate business needs with long-term strategic goals, ensuring that the chosen design not only meets current requirements, but also anticipates future growth and evolving threat landscapes. This scenario is professionally challenging because a flawed design can lead to significant security vulnerabilities, operational inefficiencies, and costly rework, impacting business continuity and reputation. Adherence to best practices and regulatory frameworks is paramount to mitigate these risks. Correct approach analysis. The correct approach emphasizes a phased implementation of security controls, starting with foundational elements like network segmentation and access control, and then layering more advanced security measures. This aligns with the principle of defense in depth, a cornerstone of enterprise network security. By prioritizing foundational security, the design ensures that even if a perimeter is breached, internal systems remain protected. This approach also allows for iterative testing and validation, reducing the risk of introducing widespread issues. From a regulatory and ethical standpoint, this demonstrates due diligence in protecting sensitive data and ensuring service availability, which are often mandated by industry-specific regulations and general ethical obligations to stakeholders. Incorrect approach is analysis. Implementing a single, overarching security solution without considering network segmentation creates a flat network, where a breach in one area can easily compromise the entire infrastructure. This is a significant security and ethical failure, as it exposes all data and systems to undue risk. It also fails to meet the principle of least privilege, a fundamental security concept. Focusing solely on perimeter security while neglecting internal controls leaves the network vulnerable to insider threats or compromised internal systems. This is a regulatory failure if data protection mandates require internal security measures, and an ethical failure due to insufficient protection of user data. Adopting a wait-and-see approach to advanced security features, such as zero-trust architecture, delays the implementation of best-in-class security practices. This can be a regulatory failure if current data protection laws require proactive security measures, and an ethical failure as it represents a passive stance on protecting sensitive information and maintaining system integrity. Professional reasoning. Professionals should approach network design by first understanding the business objectives and regulatory landscape. This involves a thorough risk assessment to identify potential threats and vulnerabilities. The design process should then follow a structured methodology, prioritizing foundational security principles like segmentation and access control, and progressively layering more advanced security features. Continuous monitoring, testing, and adaptation are crucial to maintain a secure and efficient network. Decision-making should be guided by a commitment to protecting organizational assets and user data, adhering to industry best practices, and complying with all applicable regulations. Question 7. The audit findings indicate a potential weakness in the enterprise network's ability to detect and respond to unauthorized access attempts, suggesting that current security measures may not be sufficiently proactive. Which of the following design approaches best addresses this audit finding while adhering to enterprise network security best practices? Option A. Deploy additional endpoint detection and response agents on all user workstations and servers. Option B. Implement a security information and event management system integrated with network access control to correlate security events and trigger automated responses to suspicious access patterns. Option C. Increase the number of firewall access control lists to block a wider range of potentially malicious IP addresses and ports. Option D. Enhance logging on all network devices to capture more granular data about traffic flows and user activity. The correct answer is B. Implement a security information and event management system integrated with network access control to correlate security events and trigger automated responses to suspicious access patterns. Explanation. This scenario presents a common challenge in enterprise network design, balancing the need for robust security with the practicalities of operational efficiency and user access. The audit findings highlight a potential gap in the network's ability to detect and respond to unauthorized access attempts, which is a critical aspect of network security. The professional challenge lies in identifying the most effective and compliant method to address this finding, without introducing undue complexity or violating established network design principles. The correct approach represents best professional practice because it directly addresses the audit finding by implementing a mechanism for proactive threat detection and response. By leveraging existing security infrastructure and integrating it with network access control, it ensures that suspicious activities are identified and mitigated in real time. This aligns with the principles of defense in depth and zero trust, which are foundational to secure enterprise network design. Furthermore, this approach is likely to be compliant with general cybersecurity best practices and any relevant industry-specific regulations that mandate monitoring and incident response capabilities. An incorrect approach that focuses solely on increasing firewall rules without considering the context of the audit finding would be professionally unacceptable. This is because it fails to address the root cause of the audit's concern, which is the detection of unauthorized access, not just the blocking of known malicious traffic. It might also lead to an overly restrictive network, hindering legitimate user access and operational workflows, and potentially violating principles of least privilege if not carefully implemented. Another incorrect approach, such as simply increasing logging verbosity without a defined analysis or response plan, is also professionally deficient. While more logs can be useful, without a strategy to ingest, analyze, and act upon that data, it becomes an overwhelming burden and does not contribute to proactive security. This approach fails to meet the spirit of the audit finding, which implies a need for actionable intelligence and response, not just raw data. Could also be seen as a failure to implement effective security controls if the organization is not prepared to utilize the generated logs. A third incorrect approach, such as relying solely on endpoint security solutions without considering network-level detection, is incomplete. While endpoint security is vital, it is only one layer of defense. The audit finding specifically points to a network-level concern regarding unauthorized access, suggesting that network-based detection and response mechanisms are also necessary. Neglecting this aspect leaves a significant gap in the overall security posture and fails to provide a comprehensive solution to the identified vulnerability. The professional decision-making process for similar situations should involve a thorough understanding of the audit findings, a comprehensive assessment of the existing network architecture and security controls, and an evaluation of potential solutions against established design principles and relevant compliance requirements. It requires a risk-based approach, prioritizing solutions that offer the most effective mitigation of identified risks while considering operational impact and long-term maintainability. Question 8. Which approach would be most effective in designing a secure and compliant enterprise network that supports evolving business requirements? Option A. Prioritize rapid deployment of network infrastructure to meet immediate business demands, with security and compliance checks to be performed as a secondary, post-implementation phase. Option B. Focus on implementing a single, overarching security policy that is extremely restrictive to minimize all potential attack vectors, regardless of its impact on operational efficiency. Option C. Deploy the latest security hardware and software solutions available, assuming that advanced technology inherently provides the highest level of security and compliance. Option D. Implement a layered security architecture based on a comprehensive risk assessment, incorporating regular audits, and a mechanism for adapting policies to changing business needs and regulatory landscapes. Correct answer is D. Implement a layered security architecture based on a comprehensive risk assessment, incorporating regular audits, and a mechanism for adapting policies to changing business needs and regulatory landscapes. Explanation. This scenario presents a common challenge in enterprise network design, balancing the need for robust security with the operational requirements of a dynamic business environment. The challenge lies in ensuring that security policies are not only technically sound, but also adaptable to evolving business needs and regulatory landscapes without compromising compliance. Careful judgment is required to avoid overrestriction that hinders productivity or underrestriction that creates vulnerabilities. The correct approach represents best professional practice because it prioritizes a proactive, risk-based methodology aligned with established security frameworks and regulatory expectations. By conducting a thorough risk assessment, the design team can identify critical assets and potential threats, then implement controls that are proportionate to the identified risks. This aligns with the principle of least privilege and defense in depth, which are fundamental to secure network design. Furthermore, incorporating regular audits and reviews ensures that the security posture remains effective and compliant with any relevant industry standards or data protection regulations that might apply to enterprise networks. This iterative process of assessment, design, and validation is crucial for maintaining a secure and compliant network infrastructure. An incorrect approach that focuses solely on implementing the most advanced security technologies without a clear understanding of the business context or specific risks would be professionally unacceptable. This could lead to unnecessary complexity, increased operational overhead, and potentially hinder legitimate business operations, all while not necessarily addressing the most critical vulnerabilities. Such an approach fails to demonstrate due diligence in understanding the specific needs and risk profile of the enterprise, potentially leading to a design that is both ineffective and non-compliant with the spirit of security best practices. Another incorrect approach that prioritizes speed of deployment over thorough security design would be ethically and professionally unsound. Rushing the design process without adequate risk assessment or validation increases the likelihood of introducing security gaps or compliance issues. This demonstrates a lack of professional responsibility and could expose the organization to significant security breaches or regulatory penalties. It fails to uphold the professional obligation to design secure and reliable systems. The professional reasoning process for similar situations should involve a structured approach. First, clearly define the business objectives and operational requirements. Second, conduct a comprehensive risk assessment to identify critical assets, threats, and vulnerabilities. Third, design security controls based on the risk assessment, adhering to established frameworks and best practices. Fourth, validate the design through testing and simulation. Finally, establish a continuous monitoring and review process to adapt to changing threats and business needs, ensuring ongoing security and compliance. Question 9. The monitoring system demonstrates a consistent increase in latency and packet loss on a specific segment of the enterprise network. Further investigation reveals that an unauthorized network segmentation has been implemented on this segment, isolating a group of devices. What is the most appropriate initial design consideration to address this situation? Option A. Implement a quality of service (QoS) policy across the entire network to prioritize traffic and mitigate latency issues. Option B. Analyze the traffic patterns and security implications of the unauthorized segmentation to understand its impact on network performance and compliance before making any design changes. Option C. Immediately remove the unauthorized segmentation to restore network performance, and then investigate the cause of the performance degradation. Option D. Focus solely on optimizing the routing protocols on the affected segment to improve packet delivery without considering the unauthorized segmentation. The correct answer is C. Immediately remove the unauthorized segmentation to restore network performance, and then investigate the cause of the performance degradation. Explanation. This scenario presents a common challenge in enterprise network design, balancing performance optimization with security and compliance requirements. The monitoring system's demonstration of increased latency and packet loss on a critical segment, coupled with the discovery of unauthorized network segmentation, necessitates a design review that prioritizes both operational stability and adherence to established security policies. The professional challenge lies in identifying the root cause of the performance degradation, while ensuring that any remediation or redesign efforts do not inadvertently introduce new vulnerabilities or violate regulatory mandates. The need for a robust and secure network architecture is paramount, especially in environments subject to stringent data protection regulations. The correct approach involves a systematic, layered investigation that begins with validating the monitoring data, and then proceeds to analyze the network traffic patterns and the configuration of the unauthorized segmentation. This methodical process ensures that the underlying issues are accurately identified and addressed without compromising the integrity or security of the network. It aligns with best practices in network design and troubleshooting, emphasizing a data-driven and risk-aware methodology. This approach is professionally sound because it prioritizes understanding the full impact of the unauthorized segmentation on network performance and security before implementing any changes. It also implicitly considers the need to document and report such findings, which is crucial for compliance and audit trails. An incorrect approach would be to immediately revert the unauthorized segmentation without understanding its purpose or impact. This could lead to operational disruptions if the segmentation was implemented for a specific, albeit unauthorized, reason. Furthermore, it fails to address the root cause of the performance issues, which might be unrelated to the segmentation itself. Another incorrect approach would be to solely focus on optimizing traffic flow without investigating the security implications of the unauthorized segmentation. This overlooks the potential for unauthorized access or data exfiltration, which could lead to severe regulatory penalties and reputational damage. A third incorrect approach would be to implement a broad network-wide security policy update without a targeted investigation. While security updates are important, a reactive, non-specific response to a localized issue can be inefficient and may not resolve the actual problem, potentially leading to misconfigurations and further performance degradation. Professionals should approach such situations by first validating the observed anomalies with independent tools and methods. Then, they should conduct a thorough impact assessment of the unauthorized segmentation, considering both performance and security implications. This assessment should inform a design decision that either integrates the segmentation securely and with proper authorization, or removes it after ensuring no critical functions are disrupted. Documentation and communication with relevant stakeholders are essential throughout this process. Question 10. The analysis reveals that a proposed enterprise network design prioritizes rapid deployment of new services to meet aggressive business timelines. While this approach promises immediate performance gains, it introduces a new, less tested security protocol that has not undergone extensive third-party validation. Evaluating this design against industry best practices and potential future compliance mandates, which of the following represents the most professionally sound approach? Option A. Negotiate with the business to accept a slightly reduced performance level in exchange for using a well-established and thoroughly vetted security protocol. Option B. Delay the deployment of new services until a more mature and widely adopted security protocol can be integrated, even if it means missing the initial business deadlines. Option C. Implement the new security protocol as proposed, with a plan to conduct a full security audit and protocol review within 6 months of deployment. Option D. Deploy the new services using the proposed security protocol, but implement additional, compensating security controls at the network edge to mitigate potential risks. The correct answer is C. Implement the new security protocol as proposed, with a plan to conduct a full security audit and protocol review within 6 months of deployment. Explanation. The scenario presents a common challenge in enterprise network design, balancing the immediate need for network performance improvements with the long-term implications of technology choices, particularly concerning security and compliance. The core of the challenge lies in evaluating different design approaches, not just on their technical merits, but also on their adherence to established best practices and potential regulatory impacts, even if not explicitly stated as a direct regulatory violation in the immediate context. The correct approach emphasizes a holistic evaluation that considers the security posture, scalability, and maintainability of the proposed network design. This aligns with professional best practices in network engineering, which mandate a proactive approach to security and a design that can adapt to future requirements and threats. From a regulatory and ethical standpoint, choosing a solution that inherently strengthens security and provides a clear path for future compliance is paramount. It demonstrates due diligence and a commitment to protecting organizational data and operations, which indirectly supports adherence to various data protection and privacy regulations that are standard in enterprise environments. Incorrect approaches fail by prioritizing short-term gains or overlooking critical design principles. One incorrect approach might focus solely on immediate cost savings without adequately assessing the security risks introduced or the long-term operational overhead. This can lead to vulnerabilities that, if exploited, could result in significant financial penalties and reputational damage, violating the spirit of regulatory compliance even if no specific regulation is directly breached by the initial design choice. Another incorrect approach might overlook the importance of standardization and vendor best practices, opting for a proprietary or less tested solution. This can lead to vendor lock-in, increased complexity in troubleshooting, and a reduced ability to integrate with future security tools or compliance frameworks, thereby creating an environment that is more susceptible to non-compliance and security incidents. Professionals should employ a decision-making framework that begins with a thorough understanding of business requirements, including performance, security, and compliance objectives. This is followed by an evaluation of potential design solutions against these requirements, considering not only technical feasibility, but also the long-term operational, security, and compliance implications. A risk-based assessment should be conducted for each viable option, prioritizing solutions that offer a robust security foundation and a clear path to meeting evolving regulatory landscapes. Question 11. The monitoring system demonstrates intermittent packet loss on a critical segment of the enterprise network, impacting voice and video conferencing services. The network design includes multiple Cisco routers, switches, and firewalls. Which of the following diagnostic and remediation strategies is the most professionally sound and compliant with general network design best practices for enterprise environments? Option A. Immediately adjust quality of service, (QoS), policies across all network devices to prioritize voice and video traffic, assuming that congestion is the primary cause of packet loss. Option B. Begin by examining the physical layer for any cabling issues or port errors on the affected switches and routers, Then proceed to verify Layer 2 configurations, VLAN, spanning tree protocol, and Layer 3 routing adjacencies and path selection before considering higher layer protocols or application-specific configurations. Option C. Focus solely on firewall logs and rule sets, hypothesizing that a recent security policy change is inadvertently dropping packets related to the affected services. Option D. Implement a network-wide configuration rollback to the last known stable state without performing any specific diagnostics to quickly restore service. The correct answer is B. Begin by examining the physical layer for any cabling issues or port errors on the affected switches and routers. Then proceed to verify Layer 2 configurations, VLAN, spanning tree protocol, and Layer 3 routing adjacencies and path selection before considering higher layer protocols or application-specific configurations. Explanation: this scenario presents a professional challenge because it requires balancing network performance optimization with the potential for unintended consequences that could impact user experience and compliance. The core issue is identifying the root cause of intermittent packet loss in a critical enterprise network segment. A hasty or incomplete diagnostic approach can lead to misconfigurations, further degradation of service, and potential breaches of service-level agreements, SLAs, or even regulatory requirements if the network supports regulated services. The correct approach involves a systematic layered troubleshooting methodology, starting with the most fundamental network layers and progressively moving up. This aligns with best professional practices for network design and troubleshooting, emphasizing data-driven decisions and minimizing disruption. Specifically, verifying physical layer integrity, cabling port status, then data link layer VLAN, MAC addresses, and network layer IP addressing. Routing before examining higher layers is crucial. This methodical process ensures that the simplest and most common causes are ruled out first, preventing unnecessary complexity and potential misdiagnosis. This approach is ethically sound as it prioritizes maintaining network stability and service availability, which are fundamental responsibilities of network professionals. An incorrect approach would be to immediately implement broad, sweeping changes without a clear understanding of the problem's scope or origin. For instance, randomly adjusting quality of service, (QoS) parameters without identifying the specific traffic experiencing loss is a prime example of a flawed strategy. This could lead to legitimate traffic being deprioritized, causing further performance issues and potentially violating internal policies or external SLAs that guarantee certain levels of service for specific applications. Another incorrect approach would be to solely focus on software-based solutions, such as firewall rule modifications, without first verifying the underlying network infrastructure. This ignores the possibility of physical or link layer issues, which are often simpler to resolve and can have a cascading effect on higher-level services. Such an approach risks introducing new security vulnerabilities or network instability by altering configurations without a clear diagnostic rationale, which is professionally irresponsible and potentially unethical if it leads to service disruption or data compromise. Professionals should employ a structured troubleshooting framework, such as the OSI model or a similar layered approach, to diagnose network issues. This involves forming a hypothesis, testing it systematically, and iterating until the root cause is identified. Documenting each step, the observations made, and the changes implemented is critical for accountability and knowledge sharing. When faced with intermittent issues, leveraging network monitoring and analysis tools to capture data during periods of degradation is paramount. This data-driven approach ensures that decisions are based on evidence rather than assumptions, leading to more effective and sustainable solutions. Question 12. Cost-benefit analysis shows that implementing a new, Advanced Intrusion Prevention System (IPS) would significantly enhance the organization's security posture against emerging threats. However, the proposed solution requires a complete overhaul of the existing network security infrastructure and a substantial upfront investment. The IT department is under pressure to deploy a solution quickly to address recent security advisories. Which of the following approaches best balances immediate security needs with long-term network stability and cost-effectiveness? Option A. Selecting the cheapest available IPS solution on the market, regardless of its integration capabilities or long-term support, to minimize upfront expenditure. Option B. deferring the IPS implementation and relying solely on enhanced configuration of existing security tools, as the cost of a new system is prohibitive and the risk of disruption is too high. Option C, immediate deployment of the comprehensive new IPS across the entire network to ensure maximum protection against all current and future threats, accepting the associated disruption and cost. Option D, a phased implementation of the new IPS, starting with a pilot deployment in a non-critical segment of the network, followed by gradual integration into the core infrastructure, while leveraging existing firewall capabilities for initial threat mitigation. The correct answer is D, a phased implementation of the new IPS, starting with a pilot deployment in a non-critical segment of the network, followed by gradual integration into the core infrastructure, while leveraging existing firewall capabilities for initial threat mitigation. Explanation: scenario analysis. This scenario presents a common challenge in enterprise network design, balancing the immediate need for enhanced security with the long-term implications of technology adoption and vendor lock-in. The professional challenge lies in evaluating not just the technical merits of a solution, but also its strategic fit, cost-effectiveness over its lifecycle, and adherence to established security best practices and potential regulatory compliance requirements, even if not explicitly stated in the prompt. The pressure to implement a solution quickly can lead to overlooking critical long-term considerations. Correct approach analysis. The correct approach prioritizes a phased implementation that leverages existing infrastructure where possible and integrates new security technologies in a controlled manner. This demonstrates best professional practice by minimizing disruption, allowing for thorough testing and validation at each stage, and providing opportunities to adapt based on real-world performance. It aligns with principles of responsible technology deployment, ensuring that security enhancements are robust and sustainable without introducing undue risk or operational overhead. This approach also implicitly supports a more adaptable and resilient network architecture, which is a cornerstone of modern enterprise network design. Incorrect approaches analysis. Implementing a single, comprehensive security solution without a phased rollout introduces significant risk. It can lead to unforeseen compatibility issues, operational disruptions, and a higher likelihood of security gaps if the solution is not fully understood or properly configured. This approach fails to demonstrate due diligence in risk management and can result in a less secure and less stable network. Adopting a solution solely based on its perceived advanced features, without a thorough evaluation of its integration with the existing environment and its long-term operational costs, is professionally unsound. This can lead to vendor lock-in, increased complexity, and a failure to achieve the desired return on investment, potentially violating principles of prudent financial management and strategic planning in IT infrastructure. Focusing exclusively on the lowest upfront cost without considering the total cost of ownership, including maintenance, support, training, and potential future upgrades, is a common pitfall. This can result in a solution that is cheaper initially but more expensive and less effective in the long run, potentially compromising security and operational efficiency. This approach neglects the professional responsibility to ensure long-term value and sustainability. Professional reasoning. Professionals should approach such decisions by first clearly defining the security objectives and then evaluating potential solutions against these objectives, considering technical capabilities, integration feasibility, operational impact, and total cost of ownership. A phased implementation strategy, coupled with rigorous testing and validation, is crucial for mitigating risks and ensuring successful deployment. Continuous evaluation and adaptation are key to maintaining a secure and efficient enterprise network. Question 13. During the evaluation of a new enterprise network design for a financial services firm, a key requirement is to implement robust security measures to protect sensitive customer data, while ensuring high availability and low latency for trading applications. The design team is considering various methods to segment critical data segments from less sensitive areas and to control traffic flow between these segments. Which of the following approaches best addresses these competing requirements in a professionally sound and effective manner? Option A. Implementing a comprehensive network segmentation strategy using VLAN and access control lists, ACL, at the distribution layer switches, coupled with a next-generation firewall at the network edge for advanced threat inspection and policy enforcement. Option B. Implementing strict Overly granular firewall rules on every access layer switch to block all traffic by default, requiring explicit permits for every single communication flow. Option C. Utilizing a broad, flat network architecture with minimal segmentation and implementing endpoint security solutions on all user devices to detect and mitigate threats. Option D. Deploying a single, high-throughput firewall at the internet egress point to inspect all inbound and outbound traffic, relying on this device to enforce all segmentation and access policies. The correct answer is A. Implementing a comprehensive network segmentation strategy using VLAN and access control lists, ACL, at the distribution layer switches, coupled with a next-generation firewall at the network edge for advanced threat inspection and policy enforcement. Explanation. This scenario presents a common implementation challenge in enterprise network design, balancing the need for robust security with the practicalities of network performance and user accessibility. The challenge lies in selecting the most appropriate security mechanism that aligns with the organization's risk tolerance, compliance requirements, and operational capabilities. A deep understanding of the 300-420 ENSLD exam objectives, particularly concerning security design principles and implementation considerations, is crucial. The correct approach involves a thorough assessment of the specific threat landscape, the sensitivity of the data being protected, and the performance implications of different security solutions. It prioritizes a layered security strategy that integrates multiple security controls, ensuring that no single point of failure exists. This approach is best professional practice because it demonstrates a proactive and comprehensive security posture, aligning with the principle of defense in depth. It also ensures compliance with general data protection principles and industry best practices for network security, which are implicitly expected in professional network design, even without explicit regulatory mandates for this specific exam context. The focus is on achieving security objectives without unduly hindering legitimate network operations. Incorrect approaches often stem from a superficial understanding of security requirements or a tendency to oversimplify complex issues. Implementing a single, broad security control without considering its impact on network performance or user experience can lead to operational inefficiencies and user frustration, potentially undermining the overall security goals. Relying solely on perimeter security, for instance, fails to address insider threats or lateral movement within the network, representing a significant ethical and professional oversight in comprehensive network defense. Similarly, deploying overly restrictive access controls without proper justification or a clear policy can violate principles of least privilege and hinder necessary business functions, creating an environment where users may seek unauthorized workarounds, thus increasing risk. The failure to consider the performance impact of security measures can also lead to network degradation, impacting business continuity and potentially violating service-level agreements, which is a professional failing. Professionals should approach such decisions by first clearly defining the security objectives and constraints. This involves understanding the organization's risk appetite, regulatory obligations, if any are specified for the context, and the criticality of different network resources. Subsequently, they should evaluate potential solutions against these objectives, considering not only their security effectiveness, but also their impact on performance, scalability, manageability, and cost. A phased implementation and rigorous testing are also vital to ensure that the chosen solution meets all requirements without introducing unintended consequences. Question 14. The evaluation methodology shows that a new enterprise network deployment is behind schedule due to unforeseen integration challenges with security appliances. The project manager is pushing for immediate deployment of core network services, suggesting that security configurations can be finalized and applied post-launch to meet the deadline. What is the most professionally responsible approach to address this situation? Option A. Proceed with the core network service deployment as requested, with a plan to retroactively implement security configurations and conduct testing. Option B. Reevaluate the project scope to identify non-critical services that can be deferred, allowing more time for the secure integration of essential security appliances. Option C. Deploy the core network services using basic, default security settings and prioritize the integration of security appliances in a subsequent phase. Option D. Delay the core network service deployment until all security appliance integrations and testing are successfully completed and validated. The correct answer is D. Delay the core network service deployment until all security appliance integrations and testing are successfully completed and validated. Explanation: this scenario presents a professional challenge rooted in the inherent tension between rapid deployment and robust security design within enterprise networks. The pressure to deliver a functional network quickly can lead to compromises in security posture, potentially exposing the organization to significant risks. Careful judgment is required to balance these competing demands, ensuring that security is not an afterthought but an integral part of the design process. The correct approach represents best professional practice because it prioritizes a comprehensive security assessment and design asterisk before asterisk implementation. This aligns with the principles of secure by design, a fundamental tenet in network engineering. By integrating security considerations from the outset, potential vulnerabilities are identified and mitigated early, which is far more cost-effective and less disruptive than addressing them after deployment. This proactive stance also demonstrates adherence to industry best practices and potentially regulatory requirements, depending on the specific jurisdiction. Though for this exam, we focus on general principles of responsible network design that mandate a reasonable level of security to protect sensitive data and maintain service availability. An incorrect approach that bypasses thorough security design and testing before deployment is professionally unacceptable. It represents a failure to uphold the duty of care expected of a network designer. Such an approach could lead to significant security breaches, data loss, and reputational damage for the organization. Ethically, it is a dereliction of professional responsibility to knowingly deploy a network without adequate security controls. From a regulatory perspective, depending on the industry and data handled, such negligence could result in severe penalties, fines, and legal liabilities for both the individual and the organization. Another incorrect approach, focusing solely on the lowest cost for network components without considering their security features or compatibility with the overall security architecture, is also professionally unsound. While cost is a factor, it should not supersede security and functionality. This approach demonstrates a lack of holistic design thinking and can lead to the introduction of insecure or incompatible devices that create backdoors or weaken the network's defenses. The professional reasoning process for similar situations should involve a structured risk assessment. This includes identifying potential threats, vulnerabilities, and the impact of a security incident. Based on this assessment, security requirements should be defined and integrated into the network design. A phased implementation with rigorous testing at each stage, including security testing, is crucial. Finally, continuous monitoring and adaptation of the security posture are essential in the face of evolving threats. Question 15. The monitoring system demonstrates a sudden, significant increase in outbound traffic from a specific server to an unknown external IP address, coinciding with a spike in CPU utilization on that same server. The traffic pattern is unusual and does not align with any documented legitimate application behavior. Option A. Initiate a full network scan from the affected server to identify any malware that might be causing the unusual behavior. Option B. Log the event and continue monitoring, as the alert is not currently impacting end-user functionality. Option C. Correlate the anomalous traffic with current threat intelligence feeds and review internal security policies to determine if the traffic signature matches known malicious activities or violates established security controls. Option D. Immediately isolate the affected server from the network to prevent any potential data exfiltration or further compromise. The correct answer is C. Correlate the anomalous traffic with current threat intelligence feeds and review internal security policies to determine if the traffic signature matches known malicious activities or violates established security controls. Explanation: this scenario presents a professional challenge because network monitoring tools are essential for maintaining network health and security, but their interpretation requires a nuanced understanding of potential causes and their implications. The challenge lies in distinguishing between transient anomalies that are benign and those that indicate a genuine security threat or a critical performance degradation requiring immediate intervention. Misinterpreting these alerts can lead to either unnecessary panic and resource misallocation, or more critically, a failure to detect and respond to a real security incident, potentially violating data protection regulations and impacting business continuity. The correct approach, which involves correlating the anomalous traffic with known threat intelligence feeds and internal security policies, represents best professional practice because it employs a systematic and evidence-based methodology. This aligns with the principles of due diligence and responsible network management expected in enterprise environments. By cross-referencing with threat intelligence, the network engineer is actively seeking external validation of a potential threat, which is a standard security practice. Adhering to internal security policies ensures that any response is consistent with the organization's established risk appetite and operational procedures. This proactive and informed approach minimizes the risk of false positives and ensures that resources are focused on genuine threats, thereby upholding the organization's commitment to data security and operational integrity. An incorrect approach that involves immediately isolating the affected segment without further investigation is professionally unacceptable. This could lead to significant business disruption if the anomaly is a false positive, impacting legitimate user access and critical business operations. Ethically, this could be seen as a failure to exercise due care and diligence, as it prioritizes a potentially overzealous response over a measured and informed one. Another incorrect approach, which is to ignore the alert as it is not causing immediate user complaints, is a severe regulatory and ethical failure. This demonstrates a lack of proactive security posture and a disregard for potential threats that may be operating stealthily. Ignoring such alerts could lead to a breach of data protection regulations if sensitive data is compromised, and it represents a failure to meet the professional obligation to protect the organization's assets and data. Professionals should approach such situations by first understanding the nature of the alert. This involves gathering as much context as possible from the monitoring system itself. The next step is to contextualize the alert within the broader network environment and known security landscape. This includes consulting internal documentation, security policies, and external threat intelligence. Based on this comprehensive understanding, a risk assessment should be performed to determine the severity and potential impact of the anomaly. Finally, a decision should be made regarding the appropriate course of action, ranging from further investigation to immediate remediation, always prioritizing the protection of data and the continuity of business operations. Question 16. Regulatory review indicates a growing need for consistent security policy enforcement across a hybrid enterprise network that spans on-premises data centers and multiple public cloud providers. The organization handles sensitive customer data and must comply with stringent data privacy regulations. The current approach involves managing security controls independently within each environment, leading to operational complexity and potential security gaps. The design team is tasked with proposing a solution that ensures a unified security posture and facilitates regulatory compliance. Which of the following approaches best addresses these requirements? Option A. Focus on implementing robust network segmentation within each cloud environment, assuming intercloud communication is inherently secure. Option B. Rely exclusively on the native security tools provided by each individual cloud provider, with separate teams managing each platform. Option C. Manually configure and deploy security policies on each cloud platform and on-premises infrastructure, with periodic manual audits. Option D. Implement a cloud-agnostic security orchestration platform that provides centralized policy management and enforcement across all environments. The correct answer is D. Implement a cloud-agnostic security orchestration platform that provides centralized policy management and enforcement across all environments. Explanation: scenario analysis. This scenario presents a common challenge in enterprise network design, balancing the need for robust security with the operational requirements of a dynamic, multi-cloud environment. The challenge lies in ensuring that security policies are consistently applied and enforced across disparate cloud platforms, each with its own native security controls and APIs. The regulatory review adds a layer of complexity, requiring adherence to specific data protection and privacy standards that may vary in their interpretation and implementation across different cloud providers. Failure to achieve this consistency can lead to security gaps, compliance violations, and operational inefficiencies. Correct approach analysis. The correct approach leverages a cloud-agnostic security orchestration platform. This platform acts as a central control plane, allowing for the definition and enforcement of security policies across multiple cloud environments. By abstracting the underlying cloud-specific security controls, it ensures a unified security posture. This approach is best professional practice because it directly addresses the core challenge of multi-cloud security consistency. It aligns with regulatory requirements by enabling centralized auditing, reporting, and policy enforcement, which are critical for demonstrating compliance with data protection mandates. The ability to automate policy deployment and remediation across all cloud environments minimizes human error and reduces the attack surface. Incorrect approaches analysis, relying solely on each cloud provider's native security tools without a unifying orchestration layer, leads to a fragmented security posture. This is a regulatory and ethical failure because it creates inconsistencies in policy enforcement and makes comprehensive auditing difficult. Different providers have varying levels of security features and reporting capabilities, making it challenging to ensure that all data is protected to the same standard across all environments. This fragmentation increases the risk of misconfigurations and compliance gaps. Implementing security policies manually on each cloud platform is also a significant regulatory and ethical failure. This approach is highly prone to human error, leading to inconsistent policy application and potential security vulnerabilities. The lack of automation makes it impossible to scale effectively and respond quickly to evolving threats or regulatory changes. Furthermore, manual processes are difficult to audit, making it challenging to demonstrate compliance with data protection regulations. Adopting a security model that prioritizes network segmentation within each cloud but neglects inter-cloud communication security is a critical regulatory and ethical oversight. While internal segmentation is important, the primary concern in a multi-cloud environment is the secure transit and interaction of data between these distinct platforms. Neglecting this aspect creates a direct pathway for unauthorized access and data exfiltration between clouds, violating data protection principles and increasing the risk of significant compliance penalties. Professional reasoning. Professionals must adopt a risk-based approach, prioritizing solutions that offer comprehensive visibility and control across the entire multi-cloud ecosystem. The decision-making process should involve evaluating solutions based on their ability to enforce consistent security policies, facilitate centralized auditing and reporting, and integrate with existing security workflows. Regulatory requirements should be a primary driver, ensuring that any chosen solution can demonstrably meet the necessary compliance standards. Automation and orchestration are key to achieving both security and operational efficiency in complex, distributed environments. Question 17. The audit findings indicate that the current enterprise network security architecture is not adequately prepared to dynamically adapt to emerging threats and the rapid deployment of new business-critical applications, leading to potential vulnerabilities. Which design approach best addresses these findings while adhering to enterprise network security best practices and regulatory expectations for robust cybersecurity? Option A. Defer significant security architecture changes until a specific security incident necessitates immediate action, prioritizing operational uptime above all else. Option B. Increase the frequency of vulnerability scans and penetration tests and deploy additional endpoint detection and response (EDR) agents across all devices to enhance threat visibility. Option C. Implement a zero-trust security model that segments the network and enforces granular access controls based on user identity, device posture, and context, coupled with continuous monitoring and automated threat response capabilities. Option D. Focus solely on strengthening perimeter defenses by deploying more advanced firewalls and intrusion prevention systems at the network edge. The correct answer is C. Implement a zero-trust security model that segments the network and enforces granular access controls based on user identity, device posture, and context, coupled with continuous monitoring and automated threat response capabilities. Explanation. The scenario presents a common challenge in enterprise network design, balancing the need for robust security with the operational requirements of a rapidly evolving business environment. The audit findings highlight a potential gap in the network's ability to adapt to new threats and services, specifically concerning the implementation of security policies. This is professionally challenging because network designers are tasked with creating resilient and secure infrastructure that also supports business agility. The pressure to deploy new services quickly can sometimes lead to shortcuts or incomplete security considerations, which can have significant long-term consequences. Careful judgment is required to ensure that security is not an afterthought but an integral part of the design process from the outset. The correct approach involves a proactive and integrated security design methodology. This means incorporating security considerations into every phase of the network lifecycle, from planning and design to implementation and ongoing operations. For this specific scenario, it means reevaluating the existing security architecture to ensure it can accommodate the dynamic nature of modern enterprise threats and the introduction of new applications and services. This aligns with best professional practices by prioritizing a defense-in-depth strategy and adhering to principles of least privilege and zero trust, where applicable. The regulatory framework for enterprise network design, particularly in the context of data protection and cybersecurity, mandates that organizations implement appropriate technical and organizational measures to safeguard sensitive information and maintain service availability. A proactive approach ensures compliance with these mandates by embedding security rather than bolting it on. An incorrect approach would be to implement a reactive security posture, such as simply adding more firewall rules or intrusion detection signatures, without a fundamental redesign of the security architecture. This is professionally unacceptable because it fails to address the root cause of the audit findings, which likely point to systemic weaknesses rather than isolated incidents. Such an approach is often a temporary fix that can lead to increased complexity, higher operational overhead, and a false sense of security. From a regulatory and ethical standpoint, this reactive measure could be seen as a failure to exercise due diligence in protecting the network and its data, potentially violating data privacy regulations and cybersecurity standards that require a comprehensive and forward-looking security strategy. Another incorrect approach would be to defer security enhancements until a major security incident occurs. This is a highly risky and professionally irresponsible strategy. It demonstrates a lack of foresight and a failure to adhere to the principle of risk management, which is a cornerstone of sound network design and governance. Ethically, it places the organization and its stakeholders at unnecessary risk. Regulatory frameworks often require organizations to proactively identify and mitigate cybersecurity risks, and waiting for a breach to act is a clear violation of this principle. The professional decision-making process for similar situations should involve a thorough risk assessment, followed by the development of a security strategy that is aligned with business objectives and regulatory requirements. This strategy should be iterative, allowing for continuous improvement and adaptation to evolving threats and technologies. When faced with audit findings, the immediate step should be to understand the underlying issues and then design solutions that are sustainable and comprehensive, rather than quick fixes. This involves engaging with stakeholders, understanding the business impact of potential security gaps, and prioritizing remediation efforts based on risk. Question 18. The efficiency study reveals that the enterprise network's core routing layer is experiencing significant performance degradation, impacting critical business operations. A vendor representative approaches the network design team, offering exclusive access to pre-release performance metrics for their upcoming hardware platform, which could potentially address the identified issues. The team is considering how to proceed with the network upgrade design. Which of the following actions best upholds professional ethics and ensures the integrity of the design process? Option A. Inform the vendor that the data would be considered, but only after it has been made publicly available and validated by independent third parties. Option B. Accept the vendor's offer of proprietary data and incorporate it into the design, as it may provide a performance advantage and expedite the solution. Option C. Use the vendor's proprietary data for internal analysis, but exclude it from any formal documentation or recommendations presented to stakeholders. Option D. Politely decline the vendor's offer of proprietary, unreleased data, and proceed with the design using publicly available specifications and industry-standard benchmarks, ensuring a fair evaluation of all potential solutions. The correct answer is D. Politely decline the vendor's offer of proprietary, unreleased data, and proceed with the design using publicly available specifications and industry-standard benchmarks, ensuring a fair evaluation of all potential solutions. Explanation. The efficiency study reveals a significant performance bottleneck in the enterprise network's core routing layer, directly impacting critical business applications. The network design team, responsible for the 300-420 designing Cisco Enterprise Networks, ENSLD certification, is tasked with proposing solutions. A key ethical consideration arises when a vendor representative, aware of the upcoming network upgrade project, offers the design team access to proprietary, unreleased performance data for a new hardware platform. This data, if incorporated into the design, could strongly favor the vendor's solution, potentially at a higher cost or with less overall benefit to the organization than a more open or competitive approach. The challenge lies in balancing the desire for optimal network performance and efficiency with the principles of fair competition, transparency, and avoiding conflicts of interest. The correct approach involves rejecting the vendor's offer of proprietary, unreleased data and instead adhering to established procurement processes and publicly available performance benchmarks. This upholds the ethical obligation to act in the best interest of the organization, ensuring a fair and objective evaluation of all potential solutions. It promotes transparency by relying on documented specifications and industry-standard testing, preventing any perception of favoritism or undue influence. This aligns with professional engineering ethics that emphasize integrity, objectivity, and avoiding conflicts of interest. An incorrect approach would be to accept and utilize the vendor's proprietary data. This creates a significant conflict of interest, as the design team would be basing their recommendations on information not available to competitors, thereby undermining fair competition. It also introduces an ethical failure by potentially compromising the objectivity of the design process, leading to a solution that might not be the most cost-effective or technically superior for the organization. Furthermore, relying on unreleased data could lead to design choices based on incomplete or biased information, potentially resulting in future performance issues or vendor lock-in. Another incorrect approach would be to selectively use the vendor's data while publicly claiming an objective evaluation. This is a form of deception and misrepresentation, violating professional integrity and potentially leading to legal or contractual repercussions for the organization. Professionals should employ a decision-making framework that prioritizes ethical conduct and organizational best interests. This involves clearly identifying potential conflicts of interest, adhering to established procurement policies, seeking information from multiple, reputable sources, and documenting all design decisions and the rationale behind them. When faced with offers of preferential treatment or proprietary information, the professional response is to politely decline and reiterate commitment to a fair and objective process, escalating to management if the pressure persists. Question 19. Implementation of a new enterprise network design is underway, and a key vendor for a critical network component has offered the design team exclusive access to advanced training and a preferred partner status, which includes early access to future product roadmaps and potential cost savings on future purchases, in exchange for the team considering their solution as the primary option. The network architect must decide how to proceed. Option A. Politely decline the vendor's offer but proceed with the design without actively exploring alternative vendors, assuming the current vendor's offerings are sufficient. Option B. Formally document the vendor's offer and the team's decision-making process, ensuring all design choices are independently validated against technical requirements and industry best practices, regardless of the vendor's offer. Option C. Inform the vendor that their offer is inappropriate and cease all further discussions with them regarding the current design project. Option D. Accept the vendor's offer to gain early access to roadmaps and potential cost savings, as this could lead to a more future-proof and cost-effective design. The correct answer is B. Formally document the vendor's offer and the team's decision-making process, ensuring all design choices are independently validated against technical requirements and industry best practices, regardless of the vendor's offer. Explanation. This scenario presents a common ethical dilemma in network design where a vendor, seeking to secure a lucrative contract, offers incentives that could be perceived as influencing design decisions. The challenge lies in maintaining professional integrity and ensuring that the network design is solely based on technical merit, business requirements, and adherence to best practices, rather than external pressures or inducements. The Cisco 300-420 ENSLD exam focuses on designing robust and efficient enterprise networks, and ethical considerations are paramount to ensuring the long-term success and security of these designs. The correct approach prioritizes an objective and transparent design process by documenting all design decisions, their justifications, and ensuring that any vendor-provided information is independently validated against established technical standards and the organization's specific needs. The network architect upholds professional responsibility. This aligns with ethical guidelines that mandate impartiality and the avoidance of conflicts of interest. The focus remains on delivering the best possible network solution for the client, free from undue influence. An incorrect approach would involve accepting the vendor's offer of a preferred partner status and its associated benefits without critical evaluation. This creates a significant conflict of interest. Ethically, it compromises the architect's duty to act in the best interest of the client. It also violates principles of fair competition and transparency, potentially leading to a suboptimal design that favors the vendor's proprietary solutions over more suitable alternatives. Furthermore, it could expose the organization to risks if the chosen solutions are not truly the most effective or cost-efficient. Another incorrect approach would be to ignore the vendor's offer entirely, but proceed with a design that, coincidentally, heavily favors that vendor's products due to an unacknowledged bias or lack of thorough exploration of alternatives. While not directly accepting a bribe, this still represents a failure in due diligence and objective decision-making. It can lead to vendor lock-in and missed opportunities for innovation or cost savings that might be available from competing vendors. The professional reasoning process in such situations should involve a clear understanding of the organization's procurement policies and ethical codes of conduct. When faced with vendor incentives, the architect must 1. Identify potential conflicts of interest. 2. Document all interactions and offers. 3. Seek independent validation of vendor claims. 4. Prioritize technical requirements and business objectives above all else. 5. Consult with legal or ethics departments if unsure. The ultimate goal is to ensure that the network design is technically sound, cost-effective, and aligned with the organization's strategic goals, free from any appearance or reality of impropriety. Question 20. The performance metrics show a consistent pattern of latency spikes during peak hours on a newly deployed segment of the enterprise network, impacting critical business applications. A key stakeholder is pushing for an immediate workaround, suggesting a configuration change that bypasses a specific security inspection point to reduce processing overhead, arguing that the risk is minimal for this particular segment. As a network designer, you are aware that this segment handles sensitive customer data. What is the most appropriate course of action to address the latency issue while maintaining network integrity and compliance? Option A. Implement the stakeholder's suggested configuration change immediately to alleviate the latency issue, as the business impact of the delay is significant and the stakeholder has authorized the change. Option B. Inform the stakeholder that their suggestion is not feasible due to security policy violations and refuse to implement any changes until a perfect, risk-free solution is identified, regardless of the business impact. Option C. Apply the suggested configuration change, but only during peak hours, reverting to the secure configuration during off-peak times to minimize exposure. Option D. Conduct a thorough root cause analysis of the latency spikes. Document the potential security risks of the proposed bypass and present alternative solutions or a formal exception request process to the stakeholder, emphasizing the importance of adhering to security policies and data protection regulations. The correct answer is D. Conduct a thorough root cause analysis of the latency spikes, document the potential security risks of the proposed bypass, and present alternative solutions or a formal exception request process to the stakeholder, emphasizing the importance of adhering to security policies and data protection regulations. Explanation. This scenario presents an ethical dilemma common in network design, particularly when balancing immediate business needs with long-term security and compliance. The challenge lies in the conflict between a stakeholder's desire for rapid deployment and the network designer's responsibility to adhere to established security policies and potential regulatory requirements. The designer must navigate the pressure to compromise on best practices for expediency while upholding professional integrity and the organization's security posture. The correct approach involves a thorough risk assessment and a structured process for exception handling. This upholds professional best practices by ensuring that any deviation from standard design principles is documented, justified, and approved through a formal change management process. It prioritizes security and compliance, which are paramount in enterprise network design, and aligns with the principles of responsible engineering. Adhering to established protocols demonstrates a commitment to robust design and risk mitigation, protecting the organization from potential vulnerabilities and regulatory penalties. An incorrect approach would be to bypass established security protocols or policy to meet the stakeholders' immediate demand. This could lead to significant security vulnerabilities, making the network susceptible to breaches. Ethically, it violates the principle of due diligence and professional responsibility to design secure and reliable systems. From a regulatory standpoint, depending on the industry and jurisdiction, such a bypass could result in non-compliance with data protection laws or industry-specific security mandates, leading to fines, legal repercussions, and reputational damage. Another incorrect approach would be to ignore the stakeholders' request entirely without proper communication or justification, which could damage professional relationships and hinder project progress. The professional decision-making process in such situations should involve 1. Understanding the stakeholders' requirement and the underlying business need. 2. Evaluating the proposed design against existing security policies, best practices, and relevant regulatory frameworks. 3. Identifying any potential risks or compliance gaps introduced by the proposed deviation. 4. Communicating these risks clearly and transparently to the stakeholder. 5. Proposing alternative solutions that meet the business need while adhering to security and compliance standards, or initiating a formal exception request process with a clear justification and risk mitigation plan. 6. Documenting all decisions and communications.